Hello, today we are going to talk about the most challenging chapter of Edexcel AS Level Maths from the Pure 1, and the chapter is known as the Graphs and the Transformation. In the first video of this chapter, we are going to talk about the different types of graphs we are going to do in this chapter. And first of all, we've got a cubic and a reciprocal graph. So this is Farhan Shakil from the Republic 2.0, and now we're going to talk about the cubic and the reciprocal graphs. So first of all, the topic is a cubic graph. And whenever you're talking about the cubic graph, what does that mean? That you must be having an equation with a degree of x equals to 3. Meaning thereby, we must be having an equation like x minus 1 times x minus 2 times x minus 3. And that should be equal to y, right? So whenever you're talking about this type of a cubic graph, how would you plot this graph down? The first step is to find x-intercepts. First of all, we're going to look for the x-intercepts. In the second case, we are going to look for the y-intercept. And as soon as we have got the x and the y-intercepts, we'll get ourselves the final graph. For example, in this question, which I've got it down over here for you, if you want to find out the x-intercepts, what you're going to do, you just need to plug in y equals to 0, and you must be having x negative 1 times x negative 2 times x negative 3 equals to 0. And at the end of the day, you must be having three intercepts of x, which are going to be x equals to 1, x equals to 2, and x equals to 3. In a similar fashion, if you're looking for the y-intercepts, you just need to plug in x equals to 0. So y is equals to 0 minus 1 times 0 minus 2 times 0 minus 3. And that comes out to be negative 1 times negative 2, which is 2. 2 times negative 3 is going to be negative 6. And whenever you want to plot this function down, remember that the shape of the graph is not defined, right? But you need to cut your graph through these intercepts. So first of all, we've got 1 over here, 2 over here, and 3 over here. And then we have got negative 6 over here, something, right? So the graph would look like somehow it should be in the shape of a curve, and it might look like this. It can have different shapes, but the only thing that you need to remember is, you need to make sure that the graph is passing through all of these intercepts of x and this intercept of y. So that is how we can plot any sort of a cubic graph. Now, if you're talking about the second type of graph, and that is known as a reciprocal graph, how are you going to talk about the reciprocal graphs? Reciprocal graphs, are the graph of the function in which the denominator got some sort of a variable, right? Reciprocal graphs. At times you can have an equation like, 1 upon x, or you can have negative 1 upon x, or you can have 1 upon x square, or you can have negative 1 upon x square. So remember that the reciprocal graph would always be in the form of either k by x or y is equals to k by x square. Okay. So you've got k upon x, and then you have got y is equals to k upon x square, and then you need to plot it down. So how are you going to do that? First of all, if you've got k upon x, it depends whether k is greater than 0 or k is less than 0. If k is greater than 0, meaning thereby the numerator is positive, for example, this one, you need to plot it something like this in the first and in the third quadrant, right? And if k comes out to be less than 0, you need to plot it into the second and in the fourth quadrant, right? So that is how we can plot these things down. Now, for example, if you're talking about a quadratic reciprocal function, that might look like y is equals to k upon x square, and k could either be greater than 0 or k could either be less than 0. If k is greater than 0, you should be having a quadratic reciprocal graph that might look like this, right? Or might look like this. In the form of, when k is less than 0, you must be having a graph over here that must look like in the lower plane, something like this, right? So that is how we're going to plot these functions. And now we're just going to talk about certain questions from the book, and then we'll get to the next topic. So first of all, if you look into the book, first of all, if you're talking about the reciprocal graphs, you've got these examples, I've just talked about them. Now, if you're looking into these examples, sketch on the same diagram. If you've got y is equals to 4 upon x and y is equals to 12 by x, you can see that, first of all, the numerator in both of these cases is greater than 0, meaning thereby it is a positive number. Now, this curves belong to 4 by x and this curves belongs to 12 by x. Now, there is one very important question over here. What does this 4 and 12 explain? Remember that this 4 is the cumulative distance between these 2 points, right? That has to be 4 units. And when it is going to be 12 units, it must be this distance, somehow over here. And now if you've got negative 1 by x and negative 3 by x, forget about the negative sign, just plot them. This function goes into the second and in the third quadrant, and 1 and 3 explains the distance between them. So you've got these two graphs. This is going to be the 1 unit, right? And this is going to be the 3 units. So that is how we can plot these things down. Now, if you've got this quadratic reciprocal functions, for example, you've got 4 upon x square or 12 upon x square, you should be drawing your graphs like this. Okay. So you can find out more questions to practice in exercise 4b of this exercise. Now, if you're talking about the cubic graphs, for example, here we go with the cubic graphs. And first of all, if we've got an example like this, you've got y is equals to x minus 2, 1 minus x, and 1 plus x. First of all, you'll just get yourself the x-intercepts. And then you can have yourself the y-intercepts as well. And y-intercepts comes out to be 2, right? Negative 2. And this should be the graph, right? In a similar fashion, you can do the next question example as well. Now, if you're looking into this example number 2, you can easily solve this thing out. You've got 2 x-intercepts, which should be 1 and minus 1. You've got that, right? Over here, we would not be having the third intercept. That is why we need to leave our question as it is, right? But in this question, you can see that you've got x cubed minus 2x squared minus 3x. We do not have directly 3 x-intercepts. So what we're going to do, first of all, take x as common, and you'll be left out with something like x squared minus 2x minus 3. Then you can factorize this equation and you can have certain 2 variables like they've done over here in the example. So you've got these 3 values of x, and after you've got these 3 values of x, you can easily find out the y-intercept as well. And same is the case for this one. Now, for example, if you're looking for this one, this has to be the same thing as well. But the most important thing that you need to remember over here is that, it can have multiple shapes, as I've told you in the example earlier on. So it is even written over here that you haven't got enough information to know the exact shape of the graph. The same graph can also be drawn like this, right? So that is what we need to do about the cubic and reciprocal graphs. In the next video, I'll be talking about the transformations of both of these graphs, right? If you've liked the video, do ask me the questions in the comment section. And thank you very much.